Hello, I'm Philip. Welcome to Chemistry Class Notes. So today we're going to be looking at Waec particles, your salt analysis or qualitative analysis. So the salt that I was given was sodium nitrate and sodium carbonate, and they are expected to mix the salts, dissolve in water, then you filter. So when you mix these two salts and they dissolve them in water, of course a reaction occurs. Is a double decomposition reaction whereby the anions exchange with each other. And so when that happens, the filtrate, as you can see, will be sodium nitrate, while the residue is lead carbonate. So the test is going to be based on this guy and this guy. This is the residue, this is the filtrate. So let's do the test. Okay, the first one here, C plus distilled water plus filter. Of course, when you dissolve the salt in water, of course, then the observation is that it partially dissolves, colorless filtrate and white residue. Remember, the colorless filtrate is the sodium nitrate, while the white residue is the lead carbonate. Because that should be in your head anyway. Then the inference here that C contains both soluble and insoluble salt. The next part, but before this one, just in case they might not ask you, but I'm just imagining they ask. Just in case after this plus filter, they now say you should test the filtrate with litmus paper. You should expect that it has no action on litmus paper because the filtrate is sodium nitrate. Sodium nitrate is formed from a strong acid and a strong base, and so it will not have any effect on litmus paper in the sense that it will be neutral. So just in case they ask you, test the filtrate with litmus paper, you can say that there will be no action on litmus. The inference then would have been neutral to litmus, as if they ask you. I decided not to add it. Then the second test, that is 2 cm of the filtrate. Now we are looking at the filtrate now. 2 cm of the filtrate plus freshly prepared FeSO4 and 2 sulfate plus conc H2SO4. So this is a popular test for the confirmation of nitrate. And when that happens, when you get a beaker, you add 2 cm of the filtrate, then you add freshly prepared FeSO4, then you bend the beaker a little bit and gently pour in using a dropping pipette conc H2SO4. You will notice that a brown ring will be formed at the middle of the both layers. So here I reported it like brown ring formed at the junction of the two layers. So when that happens, that is a confirmatory test for nitrate. So yeah, I said NO3 minus confirmed. Just in case you are asked, it's possible you might be asked in the third part of the question, why in performing the brown ring test, why is FeSO4 iron 2 sulfate, why is it freshly prepared? So the simple answer is that it is, when you say freshly prepared, it means when you want to perform the experiment, you have to prepare this. Unlike this guy, this one is already there, you just bring it and add. But this guy, iron 2 sulfate, you have to prepare it when you want to perform this experiment. So the reason is that if it's not freshly prepared, it will be oxidized to iron 3 sulfate, right, by oxygen in the air. So that is the reason for freshly preparing iron 2 sulfate. It is because it will be oxidized to iron 3 by oxygen in the air, I can say in the atmosphere. So that's for that. Then the third part of the question, then now you're looking at the residue. So I said residue plus dilute HCl plus lime water. So the observation is that effervescence occurs, colorless, odorless gas evolved, which turns blue litmus paper red and lime water milky. So when that happens, you know that is carbon dioxide. That is carbon dioxide. I think there's a mistake here. Normally I'm supposed to say gas is CO2 from, I'm just going to put it here. So that's a mistake. So part of the inference, since it turns blue litmus paper red, that's an acidic gas. That's why I said gas is acidic. But again, you have to say gas is CO2 from CO2 minus. This is supposed to be on top of here, right? So this is a mistake. In case they ask this type of part of the question, you have to put this gas is CO2 on top before you put from CO2 minus. So the difference is that gas is acidic, right? And it is CO2 from CO2 minus. Or you can also say, comma, HCO3 minus. So this is a mistake. I also have put this on top. So the next part of the question. So now we have to take some portions of this mixture here. So I'm saying first portion from 3 above, which is this mixture now, plus aqueous ammonia in drops and in excess. So when you add aqueous ammonia to this first portion, so you are going to get a white gelatinous precipitate. Then when you add excess of aqueous ammonia, the precipitate remains insoluble. So I said it is insoluble. You can say insoluble or precipitate remains insoluble. So the inference here is that the cations are lead Pb2 plus or Al3 plus suspected. All right, the last part, second portion from 3 plus, this is potassium heptaoxo dichromate 6 or potassium iodide. So the observation is that a yellow precipitate is formed. So when that happens, then you know that lead Pb2 plus confirmed. So this is a confirmatory test for lead. Although there is another test, although I didn't include it for lead. When you add dilute HCl to this portion and you heat it, when you heat it, you notice that a white precipitate will be formed that dissolves on warming and reappears on cooling. You also see the difference will still be Pb2 plus confirmed. I decided not to add it here just in case there's that part of the test where you have to add HCl, then you heat it. Just know that when that happens, a white precipitate will be formed that dissolves on warming and reappears on cooling. That is also another confirmatory test for Pb2 plus. So I'm going to end here for now. Until next time.